start with what is this particular substitution, or what is the feature which is called as a substitution feature. What does this say? Now what does this say? If what we try to explain in the substitution is we can define one function in a terms of another function, right? So evaluation of such functions can be done through the substitution. Fine. Sometimes the substitution helps to simplify the computation. Now let's consider one example, right? So let's consider one simple, very simple example. Say I have written a function something like this a comma b, which is equal to a very simple function, right? 1 plus a square. So square I will write like this, a raised to 2 into b minus into bracket 1 plus b minus a, 1 plus b minus a bracket close into 1 plus a the whole square. Correct? 1 plus a the whole square. Fine. Again, it is again given as 1 plus b divided by 1 plus a square. Fine. Understood all of you? 1 plus a, 1 plus a square. Correct? So this is a whole square. Now tell me, correct, whole square into b. Now here there are few terms which are getting repeated. Yes. Now what are those terms which are getting repeated in the given expression? Can anybody tell me what are these terms which are getting repeated in the given expression? Fine. Can anybody tell me what are these terms?
1 plus a square, a
Yes,
whole square.
a whole square, right? This is also by mistake and I have written like this, a whole square, correct? So the term 1 plus a whole square is getting repeated, and even 1 plus b is also getting repeated. Correct? 1 plus whole square is also getting repeated, 1 plus a whole square is getting repeated, and 1 plus b is also getting repeated. So for a simple substitution, what we can say that assume x is equal to, what I can say, 1 plus a the whole square. Correct? And similarly, I can say y is equal to 1 plus b. So like this, we can assume that x is equal to some value and y is equal to some value. And then how I can rewrite the function? Rewrite a given function as below. So how I will write? F of a comma b is equal to 1 plus a the whole square is called as x into b minus 1 plus b is called as 1 plus b is y into, correct, y into 1 plus a the whole square, so that is your x. Am I right? All of you please please correct me if I'm going wrong somewhere. Then y, then we have y divided by 1 plus a the whole square, that is x. So this is how I try to rewrite my given function, right? So this is called as a substitution. This is called at one of the feature of your functional model, which is a substitution feature. Very simple to understand. What we do is, in substitution, generally we try to replace some part of the equation with the with another equation, right? With another variable, and then we can solve that particular part later on, right? So this is very simple part of the your functional model. What we do here, we define the function in terms of another function. So the evaluation of such functions are done through substitution, right? What does it do? It just help us to simplify our computation. You can understand from the given example also that it simplifies our computation, correct? So now the third feature was the function with,
हेलो मैम.
yes.
मैम वो 1 प्लस बी माइनस ए उसकी जगह एक्स माइनस वाई माइनस ए आएगा ना.
Where the second term or yes, that part is remaining here. That is the reason I'm saying you. If I'm wrong somewhere, please let me know. So this will be right. Am I right? Y minus a. You
Yes,
say you were trying to say the same, correct? So I have to put this in the brackets. Otherwise, that multiplication will happen before that. Okay, correct. I hope this is clear with all of you. Y minus a into x plus
Yes, ma'am.
y by x. Yeah, right. Thank you. Thank you very much. So functions with condition. Now the third feature is function with conditions. So thank you very much. This says that you all are present in the class and paying attention also. Good. So function with conditions. Now very simple. What are the conditions? What conditions you may say? See, in your 12th standard, you must have studied your chemistry experiments, right? So over there, the first statement what we say is at room temperature we found the following result. Correct. So what we say, this is the condition where we have found the given things, right? Even we have another conditions also. Say whenever you want to solve the given assignments, whenever I say, okay, do this. First condition what students will do, ma'am, please keep the deadline far away. Right? Please keep the deadline of next week. So that is a condition which we are putting before doing some task, right? So in a similar manner, we have conditions with the functions also. Why do we need a conditions for the functions? So that your scope or your function is limited, right? It defines the scope of your function from where and up to where your function will run. So condition defines the scope or the periphery of your function, right? So now suppose I want to find out the factorial of a number. I hope you know the factorial. What is a factorial? Suppose I want to know 5 factorial. Then what is 5 factorial? How 5 factorial is represented? 5 into 4 into 3 into 2 into 1. So that gives my 5 factorial, the answer for 5 factorial. Right. Now this is one of the function. I want to represent this function with a mathematical model. Correct. Now, how do we represent this factorial function in mathematical model? So I will say fact of n, right, which is equal to, this fact of n is equal to, fine. So this fact of n is given as, first it will be, see how your factorial function you define. So n, how do you define it? N into fact of n minus 1. Very simple, right? So this is going to give my answer, right? What I say, fact of 5 is equal to 5 into fact of n minus 1, that is 4. 5 minus 1, that is 4. So 5 into fact of 4, right? Then how the fact of 4 will be evaluated? It will be 5, original 5 will remain as it is, 5 into 4 into fact of 3, correct? So like this it will go on, but up to what this will go on? Can anybody tell me where to stop? What is the condition? Yes, can anybody tell me what is the condition over here where we are going to stop this calculation of factorial? Till what this will go on? Till what this will go on? See, take a simple example. I will show you. See, fact of 5. Correct. How fact of 5 is calculated? 5 into 4 into 3 into 2 into 1. Correct. At 1 we will be stopping over here. Correct. So how this will be given in the recursive form? It will be 5 into fact of 4, then 5 into 4 into fact of 3, then 5 into 4 into 3 into fact of 2, then 5 into 4 into 3 into fact of 1. Correct. And what is the answer of factorial of 1? Factorial of 1 or factorial of 0, whatever number we have, the answer is 1, right? So at this condition it will be stopping. At what condition it will be stopping? If n is equal to 0 or n is equal to, or n is equal to 1. What is the value of fact of 1? What is the value of fact of 1? Or what is the value of fact of 0? That value is my 1. So whenever I get fact of 1, my value will be 1. If I have fact of 3, then what will happen? 3 into fact of 2. Correct. Now fact of 2 find करना है. So what is the fact of 2? Fact of 2 will be 2 into fact of 1. अब क्या आया? Fact of 1 आया. और फिर यहाँ पे condition क्या दिया है मैंने? If n is equal to 1. If this n is equal to 1, that will directly gives us a constant. Till now we were having the function, recursive function call, but whenever this n reaches to 1, it is going to give me a constant, directly a constant. Understood all of you how we give the functions with a condition? Correct. Now what we can say over here? Here we say that fact function, because we have seen how to define the function. So fact functions goes from the natural number. Correct. Fact function goes from the natural number n to n. Fine. This is my how my fact function defines. Right. So we can define the function of factorial like this. Suppose we have a function of a absolute. Absolute को कैसे define करना है? Absolute of n कैसे define करते हो आप absolute value को? Absolute of n is equal to n if n is greater than 0. If it is equal to 0, then it will be absolute of n will also 0. And if it is less than 0, then that value will be minus n. So very simple. So this is how I represent the function with condition. This particular part is my condition. This I will write as otherwise. Correct? So this particular part is my condition. Understood all of you which part is called as a condition? So a condition tells us about the execution of that particular step. So that is my condition, right? So now the fourth feature, we will look at a fourth feature. Now what is this fourth feature? Fourth feature is recursive definitions. Correct? The fourth feature is this recursive definition. Now simply again, currently also we have seen the example of this factorial which gives us a recursive definition. Even in the similar manner, what does the mathematical model help us? Mathematical model help us to define the recursive definitions, right? So what we can say is functions that we have discussed till now are evaluated by the substitution or checking and evaluation of a conditions. Right. So now we will be looking at a recursive function. So let's assume that we need to find out the sum of first n elements. Correct? Sum of first n elements. Right. So how do you define the recursive function for this? So first I will write the sum will be defined something like this. Sum will be n, right? N and gives n. Like this we will define the sum. A natural number of n gives us a answer with a natural number, right? Now with more elaboration, how I will define my sum function? So sum of n is equal to, right? I will be writing with this sum of n will be equal to how the sum of n will be defined. It will be equal to how this recursive call is n plus sum of n minus 1. Correct? Am I right? I want to find out sum of five numbers, five natural numbers, 1 to 5. How I will define this 1 to how I will find the sum of 1 to 5? So I will be writing sum of 5, then 5 plus sum of 4, then 5 plus 4 plus sum of 3, then 5 plus 4 plus 3 plus sum of 2, then 5 plus 4 plus 3 plus 2 plus sum of 1. Right? So once I have and then I have to add the sum of 1 also, then 5 plus 4 plus 3 plus 2 plus 1, right? And then sum of 0. And then sum of 0 is going to return what? Sum of 0 will be n. Correct? Sum of 0 will be simply n. What is this n? N itself is a 0, right? If n is equal to 0. So whenever n is equal to 0, it is going to simply return me a constant. Whenever n is equal to 0, it simply returns me a constant. Otherwise, it has to follow this. So this is how I define the recursive function. Right. So there is a concept of inductive definitions also. So these inductive definitions are shorter than their counter representation. That is a iterative definitions. Right. So this is my inductive definition. If we, whatever we say a recursive function, this recursive functions is also called as a inductive definitions. So you can see from here that this inductive definition or this recursive definition is always shorter than the iterative definitions. Of course, there are some inherent problems with this recursive functions by nature. So we will look into that later on. And then they reduce down the efficiency of a work when we have the huge number of recursions in our program. So we need to take care of while using the recursive functions. So I hope this is understood with all of you.
Yes, ma'am.